7A continued. Now we're doing 18 was one that was left with a question mark. 18. Doubleheader outcomes and events. Suppose the New York Yankees play doubleheader, 2 games. Use win for the win and L for the loss. List all the possible outcomes for the doubleheader. It could be a win, 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 loss, loss, win, loss, loss. And if you're not a Yankee fan, we're hoping for 2 losses. But anyway, list the possible outcomes. We've done that. If we were only interested in the total number of games Yankees win, what is the possible events for this 2 games? So we're looking for wins. And that could be 0 wins, 1 win, or 2 wins for these 2 games. And those are the possible outcomes. And that's it. That's all they wanted me to list. Next one that had a question was 30. 30 says relative frequency probabilities. Halfway through the season, a basketball player hits 36 free throws out of 50. So, based on its performance to date, the relative frequency for next successful would be exactly that. Or if you want, you can multiply numerator and denominator by 2 and you get 72 out of 100, which is 0.72. So we're going to say the probability on the next shot is 7.72 or 72% if you want to think of it in percentage. 32. It says you toss 2 coins 100 times and get 0 heads 23 times, 0 heads 23. You toss what? 2 coins 100 times. So 0 heads, you get 1 head 51 times, and 2 heads 26 times. So now we're getting a probability distribution that's not theoretical. We're getting the probability distribution that is relative frequency. And do you have a reason to suspect that the coin is unfair? Well, what do we normally expect? Well, you would, since the outcomes are 2 heads, heads, head, tail, tail, head, and tail, tail, 1 head should happen half the time. Well, 51 out of 100 is close to half. 2 heads should happen 1/4 of the time, which would be 25. That's close. And 2 tails, that's close. So we have no reason to think the coin's unfair. They're close to what the theoretical probability is. So no data there. Now, if it was 51 times we got no heads, then we'd say, whoa, something's strange here, and doubt that it was fair. 36. 36 says event not occurring. 36, what's the probability of not tossing 3 tails with 3 fair coins? Not tossing 3 tails. So now we're going to do 1 minus. So because there's if we're doing 3, there's 3 here, there's actually 8 outcomes, but there's only one of them that does have 3 tails. And so 3 tails happens 1 out of the 8 times, so the probability of not getting 3 tails would be 1 minus 1/8, which is 7/8. 38. What's the probability that the next person you meet was not born in July? Well, that would be 1 minus the probability that they aren't born in July, and that's July has 31 days out of 365, and so we would have 365 over 365 minus 31 over 365, which is 3 3, 4 out of 3, 6, 5, and that's what they were hoping you would do. 39. 39. Make a probability distribution for the given set of events. The number of boys in a family with 3 children. Well, it could be 3 boys, or a boy, boy, girl, or a boy, girl, boy, or a girl, boy, boy. So there's 2 boys, or it could be then there'll be 3 ways, just reversing the B's and the G's, to having 1 boy, and there'd be 1 way to have all girls and no boys. And so the probability distribution, assuming they're equally likely, of 0 boys, 1 boy, 2 boy, or 3 boys. 0 boys happens 1 of the 8 ways. 1 boy happens just like 1 girl happens 3 out of 8. 2 boys happens 3 out of 8, and 3 boys happens 1 out of 8, making 1, 2, 3, 4, 5, 6, 7, 8 eights. That's the total. So that's the probability distribution. All right, and I'll do another page.